Okay, so you've likely heard the buzz around vibe coding. It's this idea of using AI, those big language models, to generate code just from plain English prompts.
Yeah, it sounds almost like science fiction, doesn't it? And it's definitely got people talking.
It really does. And, well, that's what we're digging into today. We want to get past that initial excitement and see what's really going on. The potential, yes, but also the pitfalls.
The actual impact on software development, right?
Exactly.
And to do that, we've looked at quite a bit of stuff, expert articles, developer chats on Reddit, seeing what people on the ground are saying, plus some research reports with actual data.
Right, trying to get a balanced view.
Yeah.
So the big question is, is vibe coding this amazing shortcut to getting more done? Or is it maybe a path to some serious technical headaches later?
That's the core of it, yeah. We want to give folks a clear picture.
Okay, so what's the main promise? Why is everyone so interested?
Well, it really boils down to speed
Yeah.
and accessibility, too. I mean, the potential speed gains are pretty dramatic.
You mean like coding faster?
Significantly faster, according to some research. McKinsey, for example, they found developers using generative AI could document code in about half the time.
Half the time. Wow.
Yeah, and writing new code in nearly half the time as well. Even optimizing existing code was almost 2/3 quicker in their study.
Those are some pretty staggering numbers. Makes you think.
Absolutely. And it's not just theoretical. You see it reflected in some online discussions too, right?
Yeah, I saw that on Reddit. People talking about building actual apps really quickly.
Exactly. There's that one example, someone built a sort of Minecraft clone in just, 4 hours using
Yeah.
AI tools. That kind of thing definitely catches your eye.
For sure. And it makes you wonder, it's not just about pro coders getting faster, is it?
No, that's a really important point. There's this idea that it could make custom software, building specific tools, much more accessible. Maybe for small businesses or individuals who just couldn't afford traditional development before.
Lowering the barrier to entry, kind of.
Potentially, yeah. It could open things up.
I also saw people talking about flow state that zone developers get into.
Uh-huh. The idea is that AI could help them get there quicker
How so?
by sort of jump-starting the process, taking care of some of the initial, maybe more repetitive setup code, letting the developer dive into the more complex logic sooner.
Right, skipping the boring parts.
Kind of. And flow state is, highly valued. It's where a lot of the best work happens, focused, productive, creative. So if AI helps with that,
That would be a big deal.
it could be. But there's always a but, isn't there? We need to look at the other side of the coin. This speed, does it come at a cost?
Okay, yeah. Let's talk downsides. I kept seeing this term, technical debt. Sounds not good.
It's definitely not good in the long run. The ZenCoder article we looked at and insights from Ben Larica really highlighted this. AI-generated code can often lack, structure.
Meaning?
Meaning it might work, but it's maybe not well organized. It might lack good documentation, making it hard to understand later. It lacks clarity.
Okay, so it's like building something fast but on shaky foundations.
That's a great analogy. You get the initial speed, but maintenance down the line becomes a nightmare. Fixing bugs, adding features, it all gets much harder and takes way longer if the code is messy or uncommented.
So it could actually slow you down eventually.
Absolutely. It can get so bad that you might need costly rewrites later on. Those initial time savings completely wiped out, sometimes worse.
And this impacts the whole project lifecycle, right? Not just one developer.
For sure. Maintenance costs go up because devs spend ages just trying to figure out the AI's code instead of building new things, bringing new people onto the team. Much harder if the code base is a tangled mess.
And you mentioned this slowdown in new features eventually.
Yeah.
That negates the whole point.
Precisely. It undermines the very promise of speed that got everyone excited in the first place.
Were there specific warning signs mentioned? Like maintainability red flags?
Yeah, there were. Things like high cyclomatic complexity.
Which means,
Basically, the code has lots of decision points, lots of different paths it can take, makes it super hard to test thoroughly and understand all the possible outcomes.
okay, complex logic.
Right. Also, duplicate code patterns. You ask the AI for similar things using slightly different prompts, and you might end up with the same logic written multiple times in slightly different ways. Very inefficient.
And confusing, I bet.
And definitely. And just unclear naming. If variables and functions have vague names, good luck figuring out what does what. It's like trying to read a map with no labels.
Okay, that paints a pretty concerning picture. So it seems like the human element is still absolutely critical here.
Crucial. That McKinsey research was very clear. These AI tools are only as good as the engineers using them. It's not magic.
A tool, not a replacement.
Exactly. And humans are needed for some very specific things, like, first off, checking the code for bugs. AI makes mistakes. It can generate flawed code or make incorrect suggestions.
So you can't just copy, paste, and trust it blindly.
Absolutely not. The McKinsey study had examples where developers had to really carefully guide the AI, almost spoon-feed it, to get it to debug things correctly or fix its own errors. You need that human quality control.
Makes sense. What else?
Context, organizational context. The AI doesn't know your specific project, your company's standards, your existing system security needs, who the users are.
Right, it lacks the bigger picture.
Precisely. The developer needs to provide all that context through careful prompting. Otherwise, the code might not fit in or might not solve the actual problem effectively. It's like having a brilliant builder who needs exact blueprints and site details.
Good analogy. And complex tasks are still tricky for AI.
Seems so. The research suggests AI does better with simpler, more direct prompts. When you need to combine lots of different pieces, integrate different frameworks, handle really complex logic, that's where it struggles more.
Big picture thinking again.
Exactly. As one developer in the study said, it's least helpful when the problem becomes more complicated. That's where human architectural thinking is still essential.
Which leads us naturally to testing, right? If the code is complex or generated quickly, how do you ensure quality?
Yeah, that's another major concern highlighted in the Zencoder piece. They often see gaps in testing with vibe-coded apps.
Like what kind of gaps?
Insufficient test coverage is a big one. If you didn't write the code yourself, maybe you don't fully grasp all its nuances, so writing comprehensive tests becomes harder or maybe gets skipped.
Okay, not testing enough corners.
Right. Also, inconsistent approaches. Different team members might test differently if there isn't a clear standard, and often there's an over-reliance on manual testing.
Clicking through the app yourself.
Yeah, which has its place, but it's slow and it's easy to miss things compared to automated tests that run consistently every time.
And these testing gaps, they have real consequences, I assume.
Oh, absolutely. More regression issues where fixing one thing breaks something else unexpectedly, release quality becomes unpredictable, you might ship bugs without realizing it, and QA cycles can get longer as testers have to do more manual checking.
So what's the fix? How do you test this stuff properly?
Well, the Zencoder article suggested some pretty standard but crucial best practices, like adopting test-driven development, or TDD.
Write the test before the code.
Exactly. You define what the code should do with the test, then have the AI generate code to pass that test. Helps ensure it meets requirements from the start.
Clever. What else?
Using continuous integration, CI pipelines, basically automated systems that run all your tests every time code changes, including AI-generated code, catches problems early.
Okay, automation is key.
And setting clear requirements for test coverage. Defining that a certain percentage of the code must be covered by tests before it can be merged. It enforces discipline.
So really doubling down on good testing practices because the code source might be less predictable.
You got it. It becomes even more important.
Now let's shift gears a bit. What about the developers themselves? How does dealing with this kind of code, good or bad, affect them, their happiness maybe?
That's a really interesting angle. There's research we saw in Ars Eve paper linking developer happiness directly to productivity.
Happy coders code better.
Essentially, yes. The paper talks about how events trigger emotions, attractors, which then affect focus and performance. Team mood matters too for cohesion and success.
So if developers are unhappy, less productive.
Seems logical, and the research backs it up. Unhappiness was linked to lower output, project delays, cutting corners on process, and importantly, lower code quality.
So it's a cycle. Bad code makes developers unhappy, and unhappy developers might write more bad code.
It can definitely become a negative feedback loop. Dealing with messy, undocumented code constantly is just frustrating. It leads to burnout, which is a huge issue.
So this whole vibe coding thing, if it leads to low-quality code bases, could actually harm the developers it's supposed to help.
That's the risk, yeah. Lower morale, burnout. That kills motivation, innovation, problem-solving, everything you need good developers for.
But is there a flip side? Could AI actually improve satisfaction sometimes?
Potentially. I mean, if it handles the truly boring, repetitive stuff, or helps you get past that blank page feeling, that writer's block, that could actually be a positive.
Right, helping with the grunt work.
Exactly. So it's not all negative. It's complex. Depends how it's used.
It really sounds like having a solid underlying plan, a structure, is key to using these tools well. Which brings us to software architecture.
Absolutely fundamental. The Cyclum article really hammered this home. Good architecture is what prevents those development slowdowns and post-deployment disasters.
It's the blueprint, right?
It's the blueprint for the whole system, how the pieces fit together, how they talk to each other, the overall organization. A solid architecture keeps things manageable, scalable.
And helps avoid meltdowns later.
Definitely. It minimizes downtime, makes things like migrating tech or handling security issues easier. The software architect is the one orchestrating all this, setting requirements, making sure the tech aligns with the business goals.
So can AI help with that? With the actual architecture?
It can assist. The Cyclum piece mentioned using LLMs to, say, generate examples of system maps or help outline data models, technologies, interfaces, even basic authentication flows.
So it can draft some parts of the blueprint.
Kind of. It can provide examples or starting points. But, and this is crucial, the strategic thinking, the high-level design choices, understanding the why behind it all, that still needs human expertise. Deep understanding of the users.
AI as an assistant architect, maybe, but not the lead architect.
That's a good way to put it. It can support, but it can't replace that strategic human oversight.
Okay. Now let's touch on some of the more critical takes.
Yeah.
The debate around the term vibe coding itself seemed pretty heated in some places.
Oh, yeah. On Reddit, places like ChatGPT coding or programming opinions were all over the map. Some people are really skeptical. They see vibe coding as just a fancy term for, well, slop coding.
Slop coding.
Yeah, just churning out low-quality code quickly without much thought for maintainability. The feeling is, maybe it's okay for a quick personal project, something that just works on my machine, but not for real products.
I saw someone call it gambling in disguise. Just throw a prompt at the AI and hope for the best.
Right. That captures the concern about lack of control and predictability. But there is another view.
The more optimistic take.
Yeah, from some experienced developers. They argue you can use these tools effectively if you set things up right first.
How so?
By establishing a clean architecture, clear requirements, solid tests first. Then you guide the AI very specifically within that structure. Use it as a targeted tool, not just a code generator.
So architect first, test first, then use AI strategically.
That's the idea. But it raises a really important question.
Which is?
How do junior developers learn? If they just rely on AI to spit out code, are they really developing the deep understanding, the problem-solving skills they need to become experienced engineers?
That's a critical point. Are they missing out on the learning process?
It's a real concern. And we haven't even really touched on security much, but quickly generated, unvetted code that could easily introduce vulnerabilities, another risk factor.
So many layers to this. Okay, bringing it together then. For someone wanting to use these AI tools, what are the practical strategies? How do you do it responsibly, sustainably?
Well, first and foremost, you have to actually read and understand the AI's code. Treat it like code from a junior teammate, like that excerpt said. Be critical.
Don't just assume it's right or optimal.
Never. Question it. Make sure it does what you think it does and doesn't have weird side effects. Then refactor it.
Clean it up.
Exactly. AI code can be messy, maybe one giant chunk. Break it down into smaller, cleaner, more modular pieces. Make it readable, maintainable. That's often a job for more senior folks.
And what about addressing the potential gaps, like missing edge cases or weak spots?
Absolutely vital. You need to actively look for those things the AI might have missed. Add error handling, consider unusual inputs, strengthen types and interfaces to make things clearer and more robust.
So add the robustness the AI might lack.
And beyond the code itself, it's about building the right culture. Team agreements on coding standards, good mentorship, actually valuing and rewarding high-quality, maintainable code, not just speed.
It comes back to good engineering practices, really.
It always does. AI is a powerful assistant, potentially, but it has to sit within that strong framework of human skill, oversight, and sound principles.
It's not a magic wand to wave away the hard parts of software engineering.
Not at all. It might change which parts are hard, but the need for skill and discipline remains.
Okay, this has been incredibly illuminating. Let's try and wrap up the key takeaways for everyone listening.
Sure. So vibe coding looks tempting with its promise of speed and easier access, right?
Yeah.
But it comes with real risks. Technical debt, code that's hard to maintain, potential quality issues. These are significant if you don't have that careful human oversight.
Right. The speed gains can be easily lost down the line if you're not careful. And these AI tools, while powerful, are assistants, not replacements for skilled developers and solid engineering discipline.
Exactly. So as you navigate this, focus on fundamentals. Understand the code, evaluate it critically, prioritize long-term quality and maintainability over just getting something working fast.
Sound advice. And maybe a final thought to leave people mulling over.
Okay.
As these AI tools get more woven into how we build software, how does that change what it even means to be a skilled developer? What new skills become essential in that future?
Ooh, that's a big question. What skills rise to the top when AI handles some of the coding? Architecture, prompt engineering, critical evaluation, testing.
Something to think about, definitely.
Yeah.
How the role itself evolves. A fascinating topic for continued exploration.